Hey, I'm Bob at I Like to Make Stuff. Today, we're gonna make a
Plinko board!
In a couple of days, I'm going to be headed down to Nashville, Tennessee, to Brightwood College, who's sponsoring this video, to work on a collaboration with some of their students. We decided to make a Plinko game, which is a pretty simple woodworking project, but then I'm going to work with them to make it a little bit more interesting. The students have some plans for some lights and switches, but we'll get to all that. First, we got to make the board. Let's do it. To make the main board here, I cut down a piece of 3/4 inch plywood to give it some structure and some strength, but I wanted it to be slick, so I cut a matching piece of this whiteboard material. You could certainly just paint the plywood as well, but this will give it a nice slick surface for the pucks to fall down on. Once I had both of those pieces cut to size, I just glued them together. I used some regular wood glue and spread all over the back of this piece, then I smeared it out to the edges to make sure that they would get fully glued down to the plywood behind them. This is a pretty hard piece to clamp, so I just used some bricks. While the board is being glued up, we're going to start working on the outer frame, and that's going to be made of 1x6s. I'm going to miter the ends of this so that I can make a 3-piece frame like this to drop that panel down in. So we just got to take this off, set the angle of this to 45 degrees, and do it. It's easy to get a really accurate tilt to the blade by using one of these digital angle gauges. They're pretty inexpensive, totally worth having around. And after I finished the angle cuts, I used that gauge again to make sure my blade was back to a perfect 90 degrees before cutting the rest of the straight cuts. So I got all the pieces cut for the frame, but before we assemble them together, I need to cut 2 dados. One for the big whiteboard to slide down in the middle, and then another thinner one for a piece of plexiglass to go on the front of the whole game. So we're gonna set up the dado stack on the table saw and cut those dados. Anytime you're cutting a dado, you want to make sure that you measure the material and get the exact right thickness, because what is sold as a 3/4 inch piece of plywood is not exactly 3/4 of an inch. And in this case, since I was gluing 2 pieces together, I wanted to make sure that I had the right thickness for the blade. And also, anytime you're making a cut like this, make sure that you're putting a lot of down pressure holding the piece all the way down onto the blade. It's going to want to push the workpiece up, and that would make a really inconsistent depth of cut. After the thick dados were cut, I moved back to the normal blade. This is so I could cut my big board down to its final dimensions. So I switched back from the dado stack to the single blade because the plexiglass that I'm going to use on this is less than 1/8 of an inch thick, which is the thickness of this blade, so this will be able to create a dado that's just fine. The board was going to set 3/8 of an inch into each one of these frame pieces, so I went around the outside of the board and drew that line, just as a point of reference. This gave me my final work area to draw in a grid for the pegs to go in. And since this is whiteboard material, I used whiteboard markers to draw out the grid. That way I could draw it on and then wipe it off whenever I'm done. One of these long squares is great for drawing a grid like this too. It makes it pretty quick and easy. I've got the grid laid out on the board, and now it's time to start drilling the holes. I've got the dowel and the right drill bit to fit this dowel, and I wanted to do some tests to make sure that everything fit well, and I'm really glad that I did. I had this offcut piece, and I did some tests of drilling, and this whiteboard material does not drill through very cleanly. So I did a bunch of different attempts and tried putting tape on them, tried to put another piece of wood on top of them, and most of the results are pretty awful. I did find one thing that worked pretty well though. I put the drill on here, got it fully up to speed before pushing down, and then didn't really push down at all. I let the weight of my hand and the weight of the drill make the hole, so it's really slow going, but in those 2 cases you can see that these holes actually look a lot better. I'm gonna go ahead and drill the holes and we'll kind of figure it out as we go. I used a punch on each one of these spots where there needed to be a dowel. This will give the drill bit a place to start so it won't wander as much. Then I put a backer board behind each one of these lines and drilled the holes. The first one was not great, but after that, they actually turned out pretty good. To cut down the dowels to the right length, I set up a stop block that was behind the blade, then pushed all of the dowels up to the stop block and then through the blade. And this is actually a safety measure so that the dowels don't bind in between the fence and the blade. After I got them all cut, I used a mallet to knock them down into the holes. They were a tight enough fit that I didn't have to use glue, and that's good because it gives me some room to adjust the height of each one individually if need be. And after they were in place, it was time to add the frame around the outside. I put some glue down in the dados and then used some brad nails to hold these pieces on the outside. Alright, I've got the frame all the way around this thing, so I'm ready to cut the plexiglass, but before I do that, I want to go ahead and put in these dividers, kind of the troughs that the pucks end up in on the bottom, and I decided to use 1/2" material for that. Now, I could just use 1/2" plywood, and that would work just fine, but you'll see the plies on the face of all these dividers, so instead, I'm going to use a 2x4 and just cut it down into 1/2" pieces. That way, it just looks like solid wood, and I won't have to edge band it or anything like that. First, I ran this piece through the saw to get rid of the rounded edge. And once I had it squared off, I cut it into smaller chunks using the same method as before. I used a spacer along the side of the fence and then a miter sled to push the piece through. Now, if you have a crosscut sled, you totally don't need to do this, but this is a great alternative if you haven't made one yet. Then I set the fence to 1/2 inch and ran all these pieces through to get several slices. I've got all these pieces cut, and these fit right here on the bottom, in between the two pegs above them. But one problem is that they have a flat top. I need them to have kind of a point, so the puck has to go one direction. So I'm gonna mark the center of each one, and then use that as a point on the sander to add a bevel to each side. I used the belt sander to get these into shape, and then went back with some sandpaper to smooth out all the edges. And while I was doing that, Josh printed out some pucks on the 3D printer. These things are all ready to be put in, and I have to glue them down to the backboard and to the bottom, but they're two different materials, so I'm gonna have to use two different kinds of glue. I could use CA on all of it, but I'm gonna put wood glue on the bottom so I can attach it to the bottom piece here, and then CA glue on the back, because that will attach better to this whiteboard material. I had a dot drawn at the point of each one of these, so I had a point of reference. I also used a square to make sure that each one of these was perpendicular to the bottom edge. Then I measured out the size for the plexiglass and cut it down on the table saw. And just a word of warning, when you cut this on a table saw, it works fine, but it shoots tiny little pieces of plastic at you. It's not comfortable, and you can see it on my face. I also left the plastic wrapping on this to protect it until we got it delivered. I slid the piece in and then realized that I actually made it too long. I had forgotten to account for the slots at the bottom, which needed to be uncovered so you could get the puck back. And to stop the plexi from going all the way down, I had to cut a small piece of pine to act as a stop. This piece also needed a small rabbet in the back side of it to accept the plexiglass. So I clamped on a piece of plywood as a sacrificial fence and put it right up against the blade. Then I ran this piece of pine through and it cut the rabbet. With that stop in place, I slid the plexiglass all the way down and then marked where I wanted it to stop at the top. From there, I cut it to its final size and slid it back into place. Next up, I wanted to add some legs to this, but first I had to test it out to make sure that it would work. I leaned the board back a little bit and figured out where I wanted the legs to start, then I measured the distance from that point to the tabletop. I cut down a couple of thin pieces of 1x4 to act as the legs. Then I used some blue tape to hold those two pieces together so that I could shape and drill them at the same time. Again, I used the digital angle gauge to find the angle that I had the board leaned at. Then I used the speed square and a ruler to transfer that to the end of my legs. On the top end of the legs, I found the center point and then used a glue bottle to make a roundover. This is really just a point of reference so that I could round over these pieces on the sander so that they were nice and smooth. Once that round over was done, I used that mark in the center to drill a hole through both legs at the same time. Then I set the miter saw to match the angle on the foot and cut that off. I marked and drilled some holes in the side panels high enough that my legs could fit on the inside of the back of the frame. Then I ran some bolts and washers through to connect the legs to the outside of the frame.
I want to make sure that both of the legs can move back and forth at the same time. So I want to lock them together with 2 stringers. And to do that, I tape them together so they're lined up. I cut these stringers, and now I'm going to trace their outline on them and then cut notches for these things to fit in. They'll be inset, which will make it a lot stronger joint, and I think some glue should hold it all together.
I set these pieces in place and traced around the outside of them. But to cut these out, you have to make sure that you don't cut on the pencil line. That's actually on the outside of the material. If you do this type of thing, make sure to cut slightly on the inside of that line. You can always cut away more if you need to. The top stringer was a little bit looser than the bottom one, so I did drive in a couple of brad nails just to hold it in place while the glue dried. I put the leg assembly back in place with the same hardware, but I added a second nut on the inside of each one of these bolts. If those are tight together, they'll stay in place and won't back themselves off. And to stop the legs from sliding back too far, I used a small piece of chain and a screw to connect it to the board.
I think that's about it as far as construction. I still have to do a little bit more sanding and add some polyurethane to this to protect the outside, but if you're looking for a really basic Plinko game that is portable, this is it. Now, like I said before, we're also going to take this down to Nashville and work with some students to add some features to it, so let's do it.
We were going to be working with some students from the electrical technician program at Brightwood College. For this type of project, I would typically use an Arduino or other microcontroller and some small electronics. But these students are learning more about home wiring and analog electrical components. So it was really interesting to talk to the instructors to find out the types of things that they were using in their courses so that we could integrate them into this project. I spent some time with the instructor, talking through the plan of what we were going to put into the board and making some adjustments to how it leaned to make sure that everything would work correctly. We prepped some of the components and put on a DIN rail on the back, as well as started to cut up the LED strips before the students got in there to help us out. We had planned on using these micro switches at the bottom of each one of the slots to turn on and off lights as the pucks landed, but when we put them in place, we realized that we had to modify them a little bit to make them work.
Also found that we had to modify the pucks. The first ones that we printed are half of this. They're too light, so we glued 2 of them back to back to make it heavier. They kind of worked, but then there was a weird groove, so instead we added a wire and just glued it down the middle. This adds weight and more of a surface to hit the switch.
We also had to play with the placement of the connectors and bend up the terminals to make sure that everything could be triggered correctly inside each one of the slots.
So now we've got the LED strip. We're gonna cut it down into small sections for each one of the bays at the bottom of the board, put on a connector, and then connect that to the switches. So just gotta cut some pieces and stick them in place.
We added a strip of LEDs up each side of the board, and then each bay at the bottom had a small strip of LEDs wired to a micro switch. We glued the LEDs onto the side so that they were out of the way of the puck, and then screwed the micro switch in place to make sure that it was hit by the puck when it fell in. We worked with the students to figure out the placement of everything and strip all of the many wires that had to connect all the pieces together. All of these wires got heat shrink tubing, and they ran through the board so that they could be bundled and connected on the back side. There was a single LED controller that was feeding power to all of this. so the long strips on the sides were constantly on, but the micro switches on the bottom were stopping power from getting to the short strips. When the puck landed on the button and pressed it, power got to the strip in that one single bay. After we had all that working, we slid the plexiglass down in place and it was ready to play. We finished it up with just enough time to show it off when I spoke to a larger group of students that evening.
This thing was a whole lot of fun, and it was really cool to work with the students on this. The coolest part for me was that I would have done this in an entirely different way using Arduinos, but they used simple components to get basically the same functions. So if you're not comfortable with an Arduino or another microcontroller, you can see that you can get a lot of the same stuff done without it. And of course, if you're not even interested in the electronics, you can skip that altogether and just make a cool Plinko board. It's a lot of fun as well. Big thanks to Brightwood College for bringing me down. Check them out right down there. If you want to see some other videos, I've got lots of different types. Check those out, and don't forget to subscribe. That's it for this one, guys. Thanks for watching. I'll see you next time. We gotta cut the miter. All right, I've got the grid late and go add some more stuff to it. Let's do it. Let me do one more.